Hey class, in today's lesson we're going to talk about logarithmic functions as inverses, which is found in section 7-3, part 1 of your book. Our objective is to write and evaluate logarithmic expressions. So, it says a logarithm base b of a positive number x satisfies the following definition. So when b is greater than 0, but b cannot equal 1, then log b of x equals y if and only if b to the y equals x. You can read log bx, which we really shouldn't read, as log base b of x. In other words, logarithm y is the exponent to which b must be raised to get x. Now, I actually do something a little different than this. I have a little bit of an easier way to understand this, so I will show you in our example. Alright, so it says, what's the logarithm form of each equation? So we have 100 equals 10 squared. Now, first of all, what I like to do is rewrite them in the form of what we're used to seeing them as, right? So normally we're used to seeing something to a power equals the answer, right? So really what I see, this 10 here is the base. This here, this 2 is the exponent. And this here is the answer. Now, notice the first letter of all of these. We have a B, we have an E, and we have an A. Now, for something to be in logarithmic form, it's really log is so in other words, log is bay. Okay, so with that being said, all you need to do is rewrite the B, the E, and the A in the correct spot. So we're going to have log, what's our base? Our base is 10. The answer that we got was 100. And the exponent, right, 10 to what power gave us 100? It was 2. So this is the correct log form. All right, let's try the next one. Again, I'm going to rewrite it as 3 to the 4th equal to 81. So again, this is the base. This is the exponent. And this is the answer. So if I rewrite this, base, B, A, the answer, and the power or the exponent is 4. So log base 3 of 81 is 4. So as long as you remember that log is bay, it makes it easy for you. Let's go ahead and do the try. So here, guys, the only thing I'm going to be doing is rewriting. Alright, so we get 6 squared equals 36. Log is bay. Log is base is 6. Answer is 36. The exponent is 2. Okay, again rewrite. This is 3 to the 0 equals 1. Log is base is 3. Answer is 1. Exponent is 0. Alright, keep going. If I rewrite this, this is really 2/3 cubed equals 8 over 27. Doesn't matter just because it's a fraction. Log of the base, which is 2/3. The answer is 8/27. The exponent is 3. And we're done. Alright, let's keep going. Now in example 2, now we're actually going to solve. So think about what you're missing. Log is BA. We're looking for the exponent. So in other words, we're saying what the base raised to what exponent. So I'm just going to put E. Actually, I shouldn't use E because I don't want you to get confused with the actual irrational E. So 8 to what power is going to give you 32? 8 to what power is going to give you 32? Now, what you have to do here, because it's not so obvious, right? We actually need to get these down to common bases. All right, we need to get these down to common bases. So what do 8 and 32 share as a common power? Think about it. The common power is 2. 2 to what power gives you 8? It's going to be 2 cubed. So 8 can be rewritten as 2 cubed and you still have an x power out there, right? 32 is really 2 to the 5th power. Now, here's the deal. This 2 to the 3rd raised to the x is really, we know, 2 to the 3x, and this is still 2 to the 5th. At this point, the bases, the common bases, can really go away. So we're left with 3x equal to 5, divide by 3, and x equals 5/3. And we are done. All right, but again, it goes back to, first of all, understanding what the question is asking you. The question is asking you to find the e of bay, and then, well, we didn't see what the common, there wasn't just a very simple answer for x here, right? So we need to find a common base, which we found here is 2, and then we solved and we found x is 5/3. All right, so we're going to practice on the next one. All right, so it says, what is the value of each logarithm? So it says log base 5 of 125. Remember, we're looking for e, right? So the base is 5. To what power, we don't know, but it's got to equal 125. Now that's simple, right? Because 5 and 125 share a common base of 5. Now, on this one, we don't really have to rewrite 125 as a common base of 5 unless you want to, because really what you should know is 5 times 5 times 5, or in other words, 5 cubed is going to equal 125. So really our answer here is 3. Okay, but I will tell you, and I'm going to erase this part here, I will tell you that if you wanted to, it's a lot of work, but you could have rewritten this as 5 to the x and 5 cubed, gotten rid of the 5's, and shown again that x equals 3. It doesn't matter. Your choice. All right, let's look at the next one. We have 4 to what power equals 32? Now 4 isn't going to get you to 32, but its common base of 2 will. This is really 2 squared to the x power equals 2 to the 5th, which is really 2 to the 2x equal to 2 to the 5th. Common bases of 2 will go away, so really I have 2x equal to 5, and so x will equal 5/2. And the last one, the base is 64. We don't know what the exponent is, or sorry, we don't know what the answer is, so we're going to have to put it 64 to what power equals 1 over 32. All right, first of all, now this 1 over 32 is kind of not so great looking at, right? So what I want you to think about is, first of all, don't get thrown off by the fact that it's a fraction, because we know if the 1 is in the numerator, it probably got there because it was some base to a negative exponent, right? So think about what 64 and 32 share in common. 64 and 32 share in common a 2, right? A base of 2. 64 is really 2 to the 6th power. So this is 2 to the 6th power raised to the x. And this is really 1 over 32, we should know is 2 to the 5th. But because it's in fraction form, this is really 2 to the 6x equal to, if I move that back to the top so that I don't see a fraction anymore, this is 2 to the negative 5th. So what's going to happen here is those common bases are going to go away, and I will get 6x equal to negative 5. Finally, if I divide by 6, x will equal negative 5/6. And we are done. All right, let's keep going. All right, so then it goes on to say a common logarithm is a logarithm with base 10. You can write a common logarithm, log base 10 of x, simply as log x without showing the 10. All right, so log base 10 of x, if ever you see that, understand it's also the same thing as log x. And vice versa. If you see log of x, know this is the same thing as log base 10 of x. All right, so it says many measurements of physical phenomena have such a wide range of values that the reported measurements are logarithms or exponents of the values, not the values themselves. So when you use the logarithm of a quantity instead of the exact quantity, you're using a logarithmic scale. So the Richter scale is an example of a logarithmic scale, and it gives logarithmic measurements of earthquakes, of earthquake magnitude, which we should know, with our recent events in Oklahoma. So This is an example of the Richter scale. The Richter scale really goes from 0 to 9, right? But it looks like it's basically powers of 30, right? Or the base is 30. And so really it might be E, whatever that energy is, right? And then it's E, I believe it's times. Sorry, I can't really see. Yep, it's E times 30. So whatever the energy released is, at the first one is E times 30, then 30 squared, then 30 cubed, and 30 to the fourth, okay? So, but just remember, it always starts at E, whatever the energy amount released is. So let's look ahead. So it says in December 2004, an earthquake with magnitude 9.3 on the Richter scale hit off the northwest coast of Sumatra. The magnitude of an earthquake that hit Sumatra in March 2005 was 8.7. The formula below compares the intensity levels of earthquakes where I is the intensity level determined by a seismograph and M is the magnitude on a Richter scale. How many times more intense was the December earthquake than the March earthquake? All right, so remember, how many times more intense was December than March? So they're talking about 2004 compared to 2005. So 2004 was 9.3, 2005 is 8.7, right? So we're saying, and now I'm going to start substituting things. Remember, I is the intensity level. We're not going to change I, right? But we are going to change M, the magnitude, because it was given to us, right? So we're going to rewrite this as log of I1 over I2 equal to equal to 9.3 minus 8.7. Now 9.3 minus 8.7, I1 over I2, is going to equal 0.6. Now at this point, this is where we're going to apply the common log thing, right? So if I see, what I really see is log x, right? But the base, right? I'm going to put this in a color. The base is really 10. And remember, if this is my answer, actually I should take that back. Really, remember, this part is really the exponent position. So for me to be able to apply this 10 now, this is really, if I want to know what the answer is, right? Because this is B, A, and E, right? The answer, which is I1 over I2, is going to be the base, which is the base, raised to the power of 0.6. Okay? And with that being said, and remember it says how many more times, so that's why we're using division. Okay? So then 10, let me go ahead and type this in so that I know I've got it right. 10 to the 0.6 is about, if I rounded to the nearest hundredth, we would get 3.98. But remember, really we're talking about the Richter scale, right? So we really need to use whole numbers, so it's really about 4. So that's how many times more intense the December earthquake was than the March earthquake. Okay? And I want to be clear about something, so I want to go back. Remember, we said December compared to March. So that's how we got the first part. But I want to kind of clear up this spot down here. So originally we weren't given a log base 10, right? Remember, if you see log of something, you have to understand that the base, because they don't tell you, is 10. So we had to put the base there. The answer was next to it, right? No matter what I saw there, that came next was the answer. And then what was in the end was the exponent, which we needed to find by subtracting what the difference of the magnitudes were. Then we needed to be able to rewrite it in a form that looked acceptable to us. And so we knew that the answer was equal to whatever the base was raised to that power. So once we did that, we found that the difference, or how many times more intense, raising 10 to the 0.6 would give us about 4. Okay, so let's do the last try as practice. So it says in 1995, an earthquake in Mexico registered 8.0 on the Richter scale. In 2001, an earthquake of magnitude 6.8 shook Washington state. How many times more intense was 1995 than 2001? So again, we're substituting log of the first one over the second one. It's going to be equal to 8.0 minus 6.8. 8.0 minus 6.8 is going to give us 1.2. Okay? Now, remember, this is base 10. So this is our base, this is our answer, this is our exponent. And really I should put it in a form that's normal to us, right? So my base would be 10 to the 1.2 equal to whatever our answer is, which is what we're looking for. On the last example I did it backwards, but we're really used to seeing something like this, right? Because we're used to seeing powers on the left side and the answer on the right, so maybe that makes a little bit more sense. So then we need to go ahead and throw this into the calculator. So 10 raised to the 1.2 is going to give us about 15.84. So we're going to say it is about 16 times more intense. And again, we're going to use, we're going to round to the nearest whole number, because saying about 15.85 times more intense doesn't make as much of an impact as if you just saying rounding it up to 16. All right. So guys, we are done. If you have any questions, be sure to come in and see me for tutoring.